Hello everyone. Today I want to talk about adding and subtracting exponents. Before I go into the meaty part of adding and subtracting exponents, I'd like to talk about the concept of exponents in general. So first we'll start with addition. You see how you add 5s to get to 20. So you go 5 plus 5 plus 5 plus 5. Okay, so the idea is, say if we had to get to 200, then we just keep adding plus 5, plus 5, plus 5. Well, one individual indicated that we could call this multiplication and just put all of these individual 5s as a number to multiply from. So to get to 20, now we say 5 times 4 instead of 5 plus 5 plus 5 plus 5. Okay, so that's how we got to multiplication. Say if we wanted to do multiplication that way. 5 times 5 times 5 times 5. What if we want to get to a number like 625? Instead of doing 5 times 5 times 5 times 5, we'd do 5 to the 4th power, 625. So basically that's the concept of exponents. Instead of writing out each 5, we do to the so-and-so power. So for this one, we did to the 4th power. That means that each term, 5 was multiplied by itself 4 times. That's the concept of exponents. Using exponents is basically like a shorthand or a shortcut for multiplication. It's easier to write 5 to the 4th power, and it's just as easy to write 625. But what if we had x's, a variable? Writing x to the 4th power is more simple or more convenient than writing x, 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 x. What if we had x to the 16th power and we had to continuously write that? Wouldn't it be inconvenient to write 16 x's all the way down? So that way we use exponents, especially with variables. Adding and subtracting exponents is fairly simple. Okay. So when you add and subtract exponents, first thing you need to do is know a couple of rules. Alright, rule 1 is the degree of the exponent has to be the same in order for the exponent to be added or subtracted. What that basically means is, let's show you. The variable, the degree. So for this exponent, the degree is 2. They basically have to be like terms in order for them to be added. Let's take an example really quickly. Let's see. Okay, are those considered like terms? No, they're not. Why? Because the degrees are different. This one is to the 4th power, and this one is to the 3rd power. So the simplest form would just be to rewrite that. Okay, so now let's look at one from the same degrees. Okay, so do you see both of them are to the 4th power? So rule 1, okay, they have to be the same degrees. Okay, great. Now what's next? What's next is you just add the coefficients. The coefficients are the numbers that's in front of the variable, meaning 5 is the coefficient of this term. When there's nothing there, what's the coefficient? Is it 0? Well, no, it's not 0. Because 0x to the 4 would be the same as just saying 0. It's 1x. So when you see nothing there, you can automatically assume that the number is to be replaced as 1. So 1 is that number right there, and since we're adding just the coefficients and we're keeping the term the same, we know that we would have x to the 4. What number would be in front? Well, we're using addition, right? So it'd be 1 plus 5. which is 6. So the answer is 6x to the 4. Let's take another example. Something fairly simple. Let's do, I like the letter T, so let's use T as the variable. Let's do 3t squared plus 2t squared. Okay, so 3t squared plus 2t squared. First thing we need to do is check the degrees, make sure they're the same. And I see, all right, degrees are, they're both 2, so they are the same. Okay, so we know that it's going to end as t squared. Now we need to know what else. Okay, the coefficients. 3 is the first one. So let's put that over to the side. Plus 2 is the second coefficient. So that would be 5. So it's 5t squared. Fairly simple, right? Okay, now let's look at subtraction. The cool thing about subtraction is it's the same exact concept. You're just subtracting the coefficients. Let's take the same exact example that we just did. 3t squared plus 2t squared equals. Okay, so we already established that the degrees are 2. So they do match. So we have t squared. Now we have to take the same coefficients. Oh, I'm sorry, I put plus. I meant minus. My apologies about that. So we have to establish that the coefficients are 3 and 2. And we take the same sign, which is subtract. 2 equals 1. And commonly, they just put t squared. You can put 1. It's still the same exact answer. 1t squared and t squared is the same. So if you want to put 1 to make yourself more comfortable, that's perfectly fine. Usually it's just t squared. I just want you to make that, in your head. Remind yourself that 1t squared is the same as t squared. Okay. Now let's take a couple of terms that are alike and not alike. Great example here. X squared plus 5x plus 7x squared. Okay, so with this, what we have is a couple of terms that are alike. We can identify that by the exponent. This one is the same. This one has none, so that means 1 is right there. So that one is not the same, but this one is the same. So we can combine like terms. We can add the like terms, or we can subtract the like terms. Whatever is in front of the coefficient that has the like term, that's what you do. So with this one, you have x squared plus 7x squared. That gets you 8x squared. Why? I added the 1 and the 7. So 8x squared. And 5x squared stays the same. Why? Because there's nothing added to it. I'm sorry, 5x stays the same, not 5x squared. Alright, so that would be the answer right there. Okay, let's look at one more, so that way I know that you get the concept. And then we can do a couple of examples. Okay, this one is going to be a big one, so let's just pay attention to this one really quickly. 14x to the third plus 2x squared plus 7x squared minus 3x to the third. Okay, so what's the first thing that we do? Combine like terms. Alright, let's identify what's like terms. In case we don't know, we look at the exponent. So 3 and 3 are alike. So this one is the same as this one. And 2 and 2 are alike. So these two are the same. 14x to the third minus 3x to the third would be 11x to the third. You remember how I got that, right? I did 14 minus 3, which is 11. And then x to the third stays the same. 2x squared plus 7x squared is, right, 9x squared. And again, all I did was add 7 and 2 and 7. That's it. All right, so that's how I got my answer. All right. I hope I explained it thoroughly to you all. And if you have any questions, you can also always contact me. And I have a couple of examples listed below for you, so that way you can practice them on your own. All right. Thanks for tuning in.